kind of have a routine. We factor, we find the factors, we separate them, we put an A and a B. Then we multiply through. For our common denominator, we get rid of our fraction, in other words. Then we take the roots. We solve each one of these factors for 0, and we plug it in. Because at one point it'll eliminate the A, then the second point it'll eliminate the B. Then we plug everything back in at the end. The only thing you have to be careful of is your fraction. You cannot leave a fraction in a numerator or a denominator of a fraction. That's called a compound fraction. So you say keep, change, flip this over. So therefore it's going to be 1 over this. Just keep track of your parentheses. And if you see enough of these, this denominator just comes into that denominator.
So we just put the bottom number at the bottom?
Actually, the bottom number is just coming right in here. When you keep, change, flip is what happens to it. Okay? All right. Again, we took our factors. When we multiplied through, made a nice little problem here. Set the factors to 0 and solved for A and B and plugged them back in. Normally what you start with is this. Normally we start with this and we say, find me a common denominator, convert my numerator, and then you start like this, gather your like terms, out comes the x's, and I end up with this. So technically the same as this. So what we're saying is, let's write this backwards. Let's decompose this thing instead of simplify it. All right, this guy, again, factor, same routine. I think it looks better with the minus if you only have one term that has a negative. It kind of looks better this way than it does this way, but it's not wrong either way. So whichever way you put it is fine with me. This guy, we found our factors. Set them equal to 0. Plug them in. As bad as they look, they came out kind of nice with an A and a B. You all good with this?
See?
See.
Can I do that one when Ashley comes back?
Yes. Yes? Yes, I can. What happens is sometimes we forget to plug it into the left side. $61. We just went over it. I just went back to it again. You watch your factors. If you get your factors wrong, it's not going to look the same. Because you plan on canceling those factors out to find your A's and B's. Okay. Are you okay? Yeah, if you get your factors wrong, then it's not going to come out to be the same answers. Okay. This guy too, we want to factor it. Multiply through by our factors. Find your A and the B. This one had fractions in them. So technically you're just taking your denominator because of your keep, change, flip, and you're dropping your denominator in here. Good. Again, make sure you get the right factors. Otherwise, there's no way you'll come up with the right answers.
if we didn't put the denominator on the bottom one, would that still be right?
And you left it to say 5 halves
Yeah.
and negative 3 halves? No.
Okay.
Well, not mathematically wrong, but you can't leave a fraction within a fraction. So we have to get rid of, it's called a compound fraction then, so we have to get rid of it. You can't leave a decimal in a fraction technically, or a fraction in a fraction.
Decimal?
Yes.
How can these bathrooms appear closed?
I think because there's no security up here, and this is where kids go to there's bad problems up here.
The hoodlums mess it up for everyone else.
The hoodlums, yes they do.
Trying to get a leak.
Dave, that's not
Sorry.
appropriate. Okay, again, if you did your reverse, negative 2 over x minus 4 plus 3 over x, there's nothing wrong with that. I tend to like, again, if I just have one negative, I use the minus in the middle. For some odd reason, it just makes it look a little better. Why they gave the graph, I don't know. The book gave this graph.
I just use it.
But what's nice about graphing is, if you put this in your y1, and you put this in your y2, even though your graph might look weird, it's still the same graph. You know you did it correctly. So, you guys have a fraction key. So it really doesn't take much to do that. So what I'm saying is this. If we took this, and we went to your y equals, except on my calculator. So we put this in. I'll just put in x times. I'll do just the way it's written. Put that in one, and then in the second one, put this in. Put in the other side of it. 3 over x. Now here's my equation. If everything is right, I should get the same graph. So first time through, that's the graph I get. And second time through, I don't see anything different happening, which means I hit the same graph. How I could tell? I just look at my table. Is my table exactly the same? If my table is exactly the same, that means I did everything right. That means yes, the left side of the equation is equal to the right side of the equation. I did break it down the right way. So it's a nice way to check on it. And last, I think this is the last one, right? Lastly, there's this one. Again, separate it. Make sure you have the right, these were perfect squares. Make sure you have the right things for this. Is give you this format. I'm going to give you this format. This is your basic quadratic, right? Now, you know how you take 2 points and you can find out the equation of a line? If you find a slope, you can use point slope form, or you can just plug your points in, find the b. You know how to do that? Right? When I give you 2 points way back in 9th grade algebra? Well, here, if I give you these 3 points and I say it fits on a parabola, can you tell me the equation of a parabola? So we call this, that's why we call it curve fitting. We do it for a parabola, we do it for a circle. So we start like this, easiest way. Run your points down like this. Put x and y. All we're going to do is substitute these in here. Notice we have 3 points. Notice we have 3 variables that we need to find, a, b, and c. We know our y and we know our x. So we're going to substitute them in there, and we're going to come up with 3 equations with 3 variables. And you know how to use the systems of equations to solve that. Okay? So, we're going to plug this in. We're going to say y equals, and put this a little closer if it helps you. So your y is 3. Your a is -1. I'm sorry, your x, you don't know a. Your x is -1. Put that in parentheses. So you're substituting in your x, you're substituting in your y. You're going to do it again for each one. Here's your y equals, your x in this case is 1. And your last one, the y equals, your x in this case is 2. Okay, so far? Okay, now we're just going to simplify these guys. We're going to say 3 is equal to, -1 squared is 1, right? So a minus b plus c. I'm just simplifying them. 1 squared is 1, so 1 is equal to a plus b plus c. You can almost see where this is going, right? 3 equations, 3 variables, systems of equations. So 6, 2 squared is 4, so 4a plus 2b plus c. These are my equations, 1, 2, 3. Now, my systems of equations says, they're all set up in the same format, a plus b plus c, so elimination works really well, adding, whatever you call it, when you combine them. Can you give me 2? If you notice, the b has a negative, right?
Yeah.
So wouldn't it be nice to just eliminate a b? Yeah. And then maybe from 1 and 3 also eliminate a b? Mm-hmm. Wouldn't that be the easiest one so far?
Yeah.
So we're going to eliminate b. So I'm going to write this, eliminate b. We got to do it twice. So we're going to take equations 1 and 3. Let's do 1 and 2, sorry, 1 and 2. And then 1 and 3. Now, what happens when I add these down? I get 4 is equal to 2a. What happens to the b? Good, we eliminated that. Plus 2c. We're going to call this a. And now we got to eliminate b again. So I like the first one, that's nice and simple. Now we got to work with the third one. Okay, so take a look and see what we can multiply one of those by. Yes. Gavin who? He's not in my class. No, okay. Alright, so we're going to multiply the first one by what?
2.
Oh, well, if we multiply it by 2, then don't we get the opposites, right? So by 2, let's just bring this down. All the way across. 6 is equal to 2a minus 2b plus 2c. We're going to add it together and hope to eliminate the same variable b. So 12 is equal to 6a, b is gone, plus 3c. We're going to call this b. This is a good review for your three systems of equations with three variables. So now we're left with 4 is equal to 2a plus 2c. That's A. And B, 12 is equal to 6a plus 3c.
So we have to subtract these as well.
Well, we can't subtract them yet. We can't add them together because their coefficients don't line up yet.
Multiply
Wait, maybe one. Can't you add it together?
Well, if you add them together, you don't eliminate a variable.
Always eliminate another one.
So I want these guys to match up and be the opposite signs.
So you put -3.
Very good. Why don't we multiply this guy by -3? And then that will be -6a, right? And we'll eliminate a. All the way across. -12 equals -6a minus 6c. I'm just going to bring this guy back over here. So when we add these together, this becomes 0, out comes the a, and -3c. So therefore, what is c equal to? 0. Okay, so we know c is 0. We back substitute, take either a or b. So let's choose a. It looks a little bit nicer, a little less numbers here. I'm going to substitute in my 0. Therefore, what is a? 2. And now I have to go back to one of my original ones that has all three of them and find C. Which one would you like to use? 2, okay. So we know A is 2, we don't know what B is, but we know C is 0. So subtract 2, so B is -1.
Wait, which equation did you use to find B?
We decided to use 2. Yeah, you can use any of them. Now, here's the next part. All I got to do now is get to make my equation. I just substitute them back in. I say A is 2, B is -1, C is 0. Isn't this the equation of a parabola? And if I put this in my calculator in y1, shouldn't I find these points? So my check would say, put this in my calculator, go to my y equals, put this in my calculator, 2x squared minus x, graph it, and just look at my key here. Do I have a -1, 3? Yep. Do I have a 1, 1? Yep. Do I have a 2, 6? Yep. Nice check, right?
What's the equation?
The equation, I'm just plugging the A and the B right back into your format. Okay? So it works nicely. You're going to get a systems of equations over here. Here's where your systems of equations is going to be. 3 equations, 3 variables. From then, you're just going to go to eliminate. Remember, whatever your first step is, if you decide to eliminate A, you have to eliminate A from both sets. Eliminate C, both 2 times. B, 2 times. You get an A and a B, and then eliminate another one. Make sense? Okay. Now, we also do this for a circle. Yikes. The circle is just a little bit tougher, but not that different. If you notice, here's your x and your y, and here's your 3 variables, D, E, and F. The other one was ABC, just because we're used to working with AX squared plus BX plus C. I could call those DEF also. But the circle, this is a standard form. This is before you actually complete your square. So this is what your circle equation would look like. Now, again, this works out kind of nice. Right here. This one you're going to see, there's not a lot of points that you can get off of a circle. So a lot of times they contain the zeros. And we're going to see some nice things happening with your zeros. Put your 3 points down here. Put X and Y above the top. We're going to substitute in your X and Y, which is here, 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 here. So 0 equals, I'm just going to put them in for now. 0 squared plus 0 squared plus D times 0 plus E times 0 plus F. We're just substituting them in right now. Next one, 0 equals, X is 0, 0 squared, Y is negative 2, in parentheses. The D wants me to use the X. The E wants me to use the Y, plus F. And last one, 0 equals, X is 3, Y is 0. The D wants me to use the X. E wants me to use the Y, plus F. Once we simplify these, they look a whole lot nicer.
Sure do.
Sure do. So, first time through, this guy says 0 is equal to what? What happens to all those zeros? F. They go away, right? 0, 0, 0, 0, 0. 0 is equal to F. That's a nice one. The next one says 0 is equal to, this is a 0, this is a 4. So what's 4 plus 0? 4. There's a 0 here, so 4. This cancels out, minus 2e plus f. Here's a 0. 9 plus 0 is 9, plus 3d. 0 cancels out, plus f. So here's our 3 equations. So a nice way to start is, let's back substitute. What can we substitute into all of those? The f. The f is 0, right? So my f is 0, so is it going to take it out of here and out of here? So I'm left with 0 is equal to 4 minus 2e, and 0 is equal to 9 plus 3d. Don't they have one equation, one variable? Uh-huh.
Shouldn't we put a negative sign in front of one of the F's before we do that? To cancel
No,
them?
no, 0, f just goes in for 0,
Oh.
right? If we plug a 0 in here, doesn't it eliminate f?
Oh, yeah.
Yeah, it eliminates. Now look how nice those are. One equation, one variable. So, let's subtract 4 from both sides. Divide by negative 2. What is e? 2. Subtract 9. Divide by 3. What is d? There you go. So, I know d is negative 3, e is 2, f is 0. All I have to do now is plug them back in. I leave my x squared plus y squared. My d is negative 3. My e is positive 2. And my f is gone. This is your standard equation for a circle. Now, the reason it looks so different from your circle is because we didn't complete the square. Normally we would complete the square and you would see it like x minus h squared plus y minus k squared equals r squared. That's the next unit we do. So this is not bad, right? Now, because we don't have an easy way to check this on your calculator, you could just take some of these points, just take like a point, plug them in, and make sure it works. Carlos? This right here. Yep, 0 equals. That's how easy it is. The circle, even though it looks worse, kind of like takes care of itself a lot because if you think about a circle, if I gave you this, x squared plus y squared equals 5 equals, let's make life easy, x squared plus y squared equals 9, what's your radius? 3. What's your center? 0, 0. So when you graph this is a point that I recognize. This is a point that I recognize. This is a point. And this is a point. Aren't these points hard to get exactly a point that we could use? A lot of times they're just irrational numbers, right? So a lot of times that's why you're seeing these with zeros in them. They come from your axis. So the circles aren't as bad as they look. And that's the end of that one. So now you know how to find an equation of a line when we give you 2 points, an equation of a parabola when we give you 3, and a circle when we give you 3 points.